Good morning, everybody. I'm going to spend a little bit of time trying to put together or bring together the use of artificial intelligence and machine learning. We had this lively discussion about how everything's been around forever and nothing's new, which is of course true, but it's about bringing it all together, right? So let's see if we can do that. You can see here a painting. It's a painting of Monsieur Edmond Bellamy. It was auctioned by Christie's October of 2018, just a few months ago, for $432,000 and $500. We'll have a very nice free gift for anybody who can guess the artist. Who is the artist? It looks very much like an impressionist, shades of Monet perhaps, maybe even some Degas. $500,000. I know many of you know that, so you can claim it. But I will, as you can see, I've cleverly sort of redacted the name of the painter, and we will reveal that a little later during this presentation. So, what am I going to talk about? We primarily are interested in digital customer onboarding. And when you want to do things digitally, the emphasis is entirely on convenience. You want to do it as easily as possible, as conveniently as possible. Someone should be able to sign up for a bank account on their couch at home. All that is great, but then there is also the security aspects of it, the regulatory aspects of it, which are always at loggerheads, right? Convenience and security are always at loggerheads. The best case scenario for a digital onboarding exercise would be someone captures a picture of their ID sitting on their couch at home, takes a selfie, and that's it, right? Because the software does the rest. It extracts all the data from the ID, it matches the biometric of the selfie, and you're done. However, as one can very easily imagine, there are several issues, there are several potential problems with this whole exercise. The first most obvious problem is matching of the selfie to the ID, right? Biometrics has been around for a long time. As the last panel reminded us again and again, nothing is new. It's been around for a long time. But biometrics has also been designed for something different. It has been designed for the purpose of matching a face with another face. The problem of matching a face versus a picture on an ID document is unique. And we'll talk about how that problem needs to be solved using machine learning, artificial intelligence, and so on. The second big problem is I need to make sure that the guy sitting on his couch at home in his underwear is actually a person, right? He's not taking the selfie of another photograph, right? So how do we do that? How do we detect liveness? The third problem is the problem of tampered identity documents. Photoshop has been around for a long time. It's very easy for me, as I've done there. I'm not a citizen of Mexico, but I've taken a Mexico identity card and I've put my photograph on it. I mean, it'll be very difficult for any of you to look at that ID document and determine that it's a fake, that it's been tampered. It'll be very difficult. So how do you do that? And the last problem that we are going to address today is that, okay, since I know how to put my face on a Photoshop document, what's to stop me from doing this for 100 or even 1,000 documents, right? And essentially open 1,000 accounts. The idea that one person equals one customer is a fundamental idea for regulators, right? If one person equals 1,000 customers, then AML goes out of the window, KYC goes out of the window, money laundering goes out of the window, everything becomes iffy, right? So these are the four problems that are major problems that we see out in the field, and I'll try to talk through how each one of them can be addressed by artificial intelligence and machine learning. So, here's what we're talking about. The first problem, right? How do I match a selfie against a photo on an ID document? Like I was saying before, the biometric engines out there have been designed to match selfies against previously taken selfies, photographs against previously taken photographs, which is quite a different challenge from matching a selfie against a photo on an ID document. And why is that? Primarily because ID documents have not been designed to be produced by machines. They've been designed to be produced by humans, right? So if you have a photograph on an ID document with a hologram across half of it, the human can still tell this is the same person, but the machine has problems, right? Similarly, you have all kinds of security features, etc., that make the photographs less legible than they normally would be, right? So it becomes a challenge to match a selfie against a photo on an ID document. It's not trivial anymore. We operate in countries where IDs are much less sophisticated altogether. I mean, these are actually very high quality IDs from a country in Southeast Asia that we work in, right? So it becomes very difficult for a machine to match a photo against a photo that is badly distorted, that's in bad shape, essentially. So we took 1,000 IDs and 1,000 ID and selfie pairs and ran them through a commercial biometric engine. Now, in this case, the red line indicates the level above which the machine would tell you that this is a positive match, right? All of these should have been positive matches. But in fact, you can see over 60% of them were failed because the photo on the ID was not as easily visible to the machine as it should have been, right? The machine is expecting 2 clean photographs, right? So it's saying a lot of these, because they are not clean photographs, are not a match. Right? What that ends up doing is saying that 60% of my customers who are trying to sign up for an account digitally sitting at home on their couch are going to be rejected, which is not an acceptable experience at all. Right? So how do we do this? How do we address, how do we use machine learning? How do we use artificial intelligence to address this problem? And we did this using a 2-channel CNN, a convolutional neural network. Typically, I mean, that's the jargon that is used for something that learns, right? A network, an artificial intelligence, a machine that can learn. And what we did is, we in the 2 channels, we separately fed it identity documents in one channel and face documents in the other channel, and trained it with 40,000 examples. So 40,000 examples of real ID documents and real faces in the real world, fed through it, and every time it is trained that I don't care whether you think this is a match or not, it should be a match, right? So over time, it learns. Over time, the machine learns that, okay, even though half the face is sort of smudged, it's still a match, right? And the important thing is, I don't have a pointer, but if you look to where it says the green little box there, where it says 1.03, what we are doing essentially is creating a series of numbers that represent the photograph on the ID document, and creating a series of numbers that represent the photograph from the selfie, and then looking how far those numbers are from each other. It's called the measuring the distance between those 2 numbers, and therefore, the smaller that number is, the more those 2 pictures are alike, right? Unlike the commercial engine, where the higher the numbers were, the better the match. In this case, the smaller the number is, the better the match, okay? And the results, so everything below the red line now is a positive match. Okay, so we missed less than 1% as false negatives after taking the same data that a commercial biometric engine is rejecting 60% of the time. After taking that data and training a neural network to understand that these small discrepancies in the image are acceptable, you end up with a 99% true positive rate, which is actually quite a decent true positive rate without affecting the false positive rate. I mean, that's the key. And I don't want to get too much into the nitty-gritty of the details here, but these are 2 numbers in biometrics that are important. The false positives and the false negatives, also called the false acceptance and the false rejection. So with the false acceptance rate the same, you can cut down the false rejection to less than 1%. Okay? So the first problem that we had was the problem of matching ID documents against selfies. The solution through a 2-pronged, a parallel neural network works very well. The second problem that we have is a problem of liveness, okay? How do you know that the guy who's taking the selfie is actually a live person and is physically present there, and somebody is not using your mobile camera to take a photograph of another photograph? And there are 2 ways that this problem has been addressed in the market generally. The first is what is called an active response. The program asks you to smile or blink, and you smile or blink, and thereby the program determines that you're a live person. And the other active response is by a head turn, right? Turn left, turn right, look up, look down, whatever it is that the programmer indicates. Again, the tussle between convenience and reality, the convenience and security is dominant again here, right? You want it to be as convenient as possible. At the same time, you want it to be spoof-proof. So the next method, and it's going to be a little video there that I'm just going to let you watch. It's only about like 20 seconds. But the video will show you how a neural network can be used, an artificial intelligence machine can be used to determine liveness. It's supposed to be the video running here, guys. Okay. Anyway, the idea here is that oh, it's running, great. So that's a live face, that's me there. And now I'm going to add in a photograph, a spoof. So you can see that using various techniques, right? We're looking at depth, we are looking at patches, we are looking at skin tone coloration, we are looking at 128 measures of color, using all of these different spectrographic techniques that are available from the image itself, and feeding all of them into a neural network. The machine is able to distinguish in real time a live face versus a face that could be a video or a spoof or whatever. There's another big requirement to be able to do digital onboarding is you've got to be sure that the person is a live person. Okay, so now back to our initial question. So now I have unmasked the artist. Okay, if anyone can pronounce that, I'll give you $100 right now. Right? It's not a person. Right? It's a program. And this program, so a lot of us worry about artificial intelligence, right? A lot of us wonder, what is it that machines can do? That 20 years from now, am I going to be in love with the machine? 20 years from now, is the machine going to be my surgeon? Is the machine going to be my doctor? Is the machine going to be my mechanic? I don't know about all of that, but the really interesting question is there are two interesting questions, right? Can a machine be sentient? Can a machine become self-aware? And I don't have the answer to that. The second important question is, can a machine be creative? We do have an answer to that. This is a portrait. It's people actually paid good money for it, so nearly $500,000 for something that was created by a machine. Now, how was this done is an interesting question, and then how do you use it in KYC is an even more interesting question. So let's see how this was done quickly. It's called this is even in machine learning and even in artificial intelligence, this is a completely new area. It's only 4 years old. It's only in the last 4 years that people came up with this idea of a generative adversarial network. It's called a GAN. A GAN is the term, if you want to look at it in the literature, they're called GANs. It's only 4 years old. So the first GAN was only 4 years ago, and today the GANs are doing tremendous stuff. So what is a GAN? A GAN is a two-pronged artificial intelligence network. One of it is generative. Think of that as the robber, okay, the thief. And the other is the adversarial network, and think of that as the cop. So it's a game of cops and robbers, okay? The adversarial network is trained using thousands and thousands of impressionist paintings by various masters, and it is told that this is a real Monet, this is a real Degas, this is a real so on and so on, so forth, right? The robber, his job is to try to fool the cop. So he literally starts off with one pixel, one dot on a blank page, and sends it to the adversary, to the cop, and says that this is a Monet. And the cop, of course, says, yeah, right. And he throws it out, right? Because he knows he's seen 1,000 Monets. But then the next time he comes back with 2 dots. The next time he comes back with 4 dots. The next time he comes back with 1,000,000 dots, right? And he does this literally 10 million, 20 million, 30 million times until it eventually fools the adversarial network into thinking that what was created, Monsieur Edmond Bellamy, is actually a legitimate piece of art created by a legitimate impressionist painter. At that point in time, the thief has been able to fool the cop and has created something unique, right? That is how this painting was created. So it's a fascinating concept. I mean, I find it endlessly fascinating. It could be used for all kinds of very, very interesting applications. But what is the application that we choose to use it in, right? So remember, this is a real ID document, the one on the right. On the left, I've just taken my face and replaced the face of the person that the ID belongs to. Okay? Any check will pass, right? If I take the ID document and send it to the issuer, it's a real document. The ID number is real. The name is real. Everything is real. The only thing that is not real is my photograph, right? So the only way the issuer of this document will be able to differentiate that this is a fake document is by matching the photograph on the document against a photograph that they have on file. But they don't offer that service, right? So what do? So what we decided to do is to say that, okay, let's take advantage of the fact that each document has two images on it. Okay, there's the photo image, and there's the little image on the right, or on the left rather, right? That image is an identical copy of the big image, except that on it has encoded the name, the ID number, the date of birth is actually printed on top of that image. Okay, so there are two things that are required. I give the GAN, I give the generative part of the network, the little image, and I train the adversarial part of the network with the big image. Okay? And the little image, the GAN, the generative network keeps trying to clean up the little image and come up with the good image until the adversarial part of the network is fooled into thinking that this is actually the same image. So essentially what has happened at that point is that all the coding on top of the image has been cleaned out. Okay. Now, this will only work because the system has been trained with real ID documents. This will only work if the little image has been created with the imprints on it in exactly the same way as the government did it in the first place, right? And which is actually what happens. So when I take the real ID, I clean up the image with all the coding on it, I get the clean image back. But when I take my face and I clean it up, because the GAN doesn't, my coding is not perfect, right? So the GAN ends up creating a very distorted face, and then I take a biometric match between the face that was cleaned up versus the face that's on the ID, and I have a very powerful way of detecting a spoofed image, right? So this is just like the Impressionist painting was created in exactly the same way. It's exactly the same technique. The last problem, I don't know how much time I have left. I have 2 minutes, good. The last problem we are trying to solve is one of impersonation. Okay, a person presenting themselves over and over again using various techniques. They could be using 5, 6 different identity documents that are real, right, which would be impossible to sort of mark, or they could be using fake documents. Right? So this is a real world example that we'll give you. We have a customer in a country in Southeast Asia, a large bank, 600 branches, 17,000 employees, which will be a surprise to many people from Europe, but in Asia, labor is cheaper. So they decided that they have about 8% of the country's population is banked, and they gave themselves the challenge of banking the rest, country of about 60 million people, in a space of 5 years, right? So how do they go about it? The only way they could go about it is by signing up loads and loads of agents. This number is a little old. Now they have about 35,000 agents, little mom and pop shops that have been signed up as correspondent banks across the country. And you've created this vast network where everybody who goes to buy milk can also sign up for a bank account, right? Of course, the regulatory aspects of it become critical. Into this project, about 6 months in 6 months, they did 2.5 million accounts, right? So significant, very significant 2.5 million accounts, significant traction. But they realized that they were open to a real threat, which was an agent signing up multiple accounts with his own photograph in each one of those accounts, right? It's someone else's name, someone else's phone number, but his own photograph. So government payment going into that account would then be accessible by the person who opened that account, because everything is biometric going on forward, right? So we decided to go through this exercise of saying, okay, let's find out, let's take every image in the database and match every agent against every customer in the database. Okay, and sure enough, as expected, we were able to find, so this whole process is called biometric deduplication, right? You need to make sure that one person can only be one customer, or one person can only be one agent. You cannot have the same person using their selfie, a real selfie, you know, live and all that, and open up many, many accounts using that one selfie, because that poses a significant threat. And sure enough, we were able to find 143 bank employees and 94 agents had created thousands of fake accounts. So we were able to identify all of them and get rid of all of them, disable all of them in a matter of hours, right? So it was a very significant step forward. And now, of course, the bank realized that every new account opened must be also deduplicated, right? So in the KYC world, this concept of biometrics, so we have normal concepts of numeric deduplication exist, right? Concepts of alpha deduplication exist, right? We have a watch list that we check names against, right? So we already have the process of deduplicating against watch lists. What we don't have is a biometric deduplication process, and that was a significant step forward using AI for KYC. It's one of my favorite sort of sayings, if you're a hammer, everything looks like a nail, right? So right now, I think AI and everything looks like the solution to everything is AI, but not everything, but certainly these kinds of things, right? You can do very significant advances in image analysis, image processing, anomaly detection, in behavior patterns using AI, as you can do significant advances in AML using AI. So that's all I have for today. I hope it was useful. Thank you very much.